Okay, so we're solving inequalities today, and when you're solving an inequality, the only thing that really changes from solving an equation is sometimes you have to flip the sign. So a less than becomes a greater than becomes a less than. And when you do that is when you find yourself multiplying or dividing both sides by a negative number. So sometimes you're going to multiply by a negative number just as part of simplifying one side. That doesn't count. It's only when you're trying to solve and you find yourself multiplying or dividing on both sides by a negative and you flip the sign. So we'll do a couple examples of this, then we'll get into the more advanced problems that involve absolute values. For this unit, we're going to leave our answers sort of in inequality form. We're not going to use interval notation in this unit, although we will be dealing with interval notation later in the year when we get into functions. So we'll start with a pretty simple example. We're going to solve this the exact same way that we would solve an equation. Depending on how we do it, we may end up dividing by a negative number, and I'm going to do it in such a way that that happens so that we can see when the sign should be flipped. So just as if this were an equation, our first step would be to get rid of those parentheses. I'm trying to simplify things as much as possible. So we'll go ahead and distribute here. And I am going to work to get all of my x's on one side, everything else on the other side. So there's a couple ways I can do this. I'm specifically going to do it this way, though, because I want to see that division by a negative. So we're subtracting x from both sides. I'm going to go ahead and add 18 to both sides in the same step. We'll get rid of our x's over here, our 18's over here. Now we've got a negative 4x over here, less than or equal to 32, and 18 gives us 50. One final step and we'll be finished here. We may have to simplify our answer, but to get x by itself, all we need to do now is to divide by a negative 4. Now we're dividing by a negative, which is going to cause our sign to flip. So it's no longer going to be greater than or equal to, it's now going to be less than or equal to. X is less than or equal to, positive divided by a negative is a negative number, 50 over 4. We just need to simplify that. We can divide both of those by 2. 50 and 4 both divide by 2. Negative 25 halves. And that's going to be the answer that we're going to give here. Now, I want to go ahead and graph this. Graphing is not very important for this particular problem, but it will be for some of the more advanced problems that we're going to do in just a minute, so we'll just practice a little bit as we go along here. So when I ask you to graph, you don't need to put a whole bunch of tick marks on your number line. In fact, for this particular problem, the only important value is the negative 25 over 2, so negative 25 over 2. We want to keep the parts of the number line that are less than that, so to the left, and we want to keep the negative 25 over 2, so I'm going to use a closed circle and then just draw a graph going off to the left. I know some of you like to draw that right on the number line. I'd encourage you to draw it above just because it's going to make things a little bit easier when we get into compound inequalities and inequalities with absolute values. Do you have a question?
Yeah, you use a bracket.
You want to use a bracket instead of a closed circle here? So you want to do this instead? Fine by me. Yep. Works for me. You're familiar with open circles, closed circles. When you see those on the graph later on, you're going to know that one of them is included and the other one's not included. Yep, that's totally fine. So brackets and parentheses work just fine. Any questions on this first one? All right. You're going to see some weird situations arise when you're working on some of the homework problems where all of your variables disappear And you're left with just an inequality that only has numbers in it, no more variables. Now, sometimes your answer is going to be no solution. Sometimes it's going to be all real numbers. And we can go ahead and abbreviate no solution using the empty set. We'll abbreviate all real numbers using the double bar R. Or you can write it out if you prefer. And which of those two answers you get depends on whether that statement is true or false. We're going to see one of each here. So both of these equations are going to cause something weird to happen once we solve. We're not going to see any variables left in the equation. One of them is going to give us a true statement. The true statement is going to get the answer all real numbers. The false statement is going to get the answer no solution. Okay. So if you'd like to go ahead and solve those out, see what I mean, you're going to see that you'll be able to eliminate all of your variables. You're going to be left with just some numbers. One number is greater than another number, or one number is less than another number. Bless you. So in the process of solving this, I try to eliminate my r's from one side of the equation. So I might say, okay, let's get rid of these r's over here, do plus 6r on both sides. But that actually ends up eliminating all of the variables, and I'm left with the equation negative 30 is greater than negative 30. Now I could do all kinds of algebra to this. I could add 30 to both sides. I could add or subtract anything I wanted to from both sides, but that statement is always going to remain the same truth value. And is that a true statement or no? Is negative 30 greater than negative 30? It is not. So this is false, which means that this inequality has no solution. This would be the answer that I would give. Or you can write out the words no solution. If that had said greater than or equal to, would that change anything? That would have made it a true statement, and then it would have been all real numbers instead. All right, second example. We distribute the negative. You combine some like terms. We could decide to eliminate our a's on one side of the equation, so adding a to both sides is actually going to eliminate the a's on both sides. And we end up with the statement that negative 12 is less than negative 9. And we could go ahead and add 12 to both sides, or we could add 9 to both sides, but the truth value of that statement is not going to change. Is that a true statement or no? Is negative 12 less than or more negative than negative 9? This is a true statement, which means our solution will be all real numbers. It means that anything we plug in for A is going to work in that inequality. Questions on these? Keep an eye out for these. They will pop up in your assignments from time to time. All right, let's move on and talk about compound inequalities. These are two inequalities that are joined together by either an and or an or. What we're going to do is we're going to solve each inequality independently. We're going to graph our solutions. And then we're going to determine our answer based off of whether it's and or or. Now, if it's and, both have to be true at the same time, meaning you're going to need to find values where those two graphs overlap, where both things are true at the same time. If it's or, we're looking for anything that's included by either one of them. All right, so we'll go ahead and solve these two separately. We'll notice that this is an and statement, so we're going to keep that and in between them each step along the way. We're going to graph both of our solutions, and we're going to look for where those two graphs overlap each other, where they intersect. So let's get this. It's negative 7x by itself. We could start by getting rid of the 9. And we can isolate that x now by dividing by negative 7 on both sides. Watch me carefully, make sure I don't screw anything up here. Any issues there? What I forget to do? Oh, I forgot to flip the sign. We did divide on both sides by a negative number. Whoops. Easy mistake to make. Easy to forget that one. So x is less than 4, and let's solve the other one. Thank you very much. And all right, getting rid of the 10. 4x is greater than or equal to negative 8. We'll divide by 4 on both sides. X is greater than or equal to negative 2. So that's it. X is greater than or equal to negative 2. Let's graph these two things and see where our graphs overlap. So when I graph, again, all I'm interested, you don't need to put tick marks all over your graph. The only things I'm really interested in are the important numbers. In that case, it'd be 4 and negative 2. Just make sure you get the bigger number on the right and the smaller number on the left. Nothing really needs to be to scale even. All right, what are we told? We're told by this statement that x is less than 4. So we're not going to include 4, but we're going to include anything that's less than 4. My second statement says that x is greater than or equal to negative 2. So this time we are going to include negative 2, and we're going to include anything greater than it as well. Our final answer is going to be the region where these two things overlap. Now, are they overlapping at negative 2? Do both graphs cover negative 2? Do both graphs include negative 2? The answer is yes. So we will include negative 2. And everything in between, they're overlapping. But are they overlapping at 4? Do they both include the value 4? No, one of them does, but the other one doesn't. So we are not going to include 4. Here's how we're going to write our answer, okay? X can fall anywhere between negative 2 and 4, right? Anywhere between negative 2 and 4. X can fall anywhere between negative 2 and 4. We're going to write this as a compound inequality. X has to be bigger than or equal to negative 2. Remember, the alligator always eats the bigger one. Remember that? From way back when. And x has to be less than 4. So this is the form I'm going to ask you to write your solutions in for now. Now we could do this in interval notation, but this is how you're going to see your answers on your answer key for right now. We will come back and deal with interval notation later on. Make sure, a couple things I want to point out, and you can make a note in your own notes right now. If you're going to write an answer like this, I want the smaller number on the left. I want the bigger number on the right. And in a situation like this where x is falling between two numbers, the signs are always going to point to the left, right? Because the smaller thing is always going to be on the left. The alligator always eats the bigger one. Okay, so these signs are always going to kind of point in this direction. As long as you got the smaller on the left, the bigger on the right. Any questions about that notation? Let's do an or. So I'd like you guys to kind of go through the first couple steps. Go ahead and solve both of those inequalities, get x by itself, graph them both. This is an or, so we are not looking for overlap this time around. When we write our answer to this one, our answer is going to have the word or in it. We won't be able to write it the same way we did the last one. So I'm hoping you got x less than -9 or x greater than -7. All right. We're going to graph these now. Let's get -9 and -7 in the correct place on the number line. So the smaller one should go to the left. -9 is the smaller of the two. -7 is the bigger. We've got one inequality telling us that x is less than -9, one inequality telling us that x is greater than -7, and we're going to keep anything that's covered by either one of these. Now we've got two separate regions here, so our answer is going to be x is less than -9 or x is greater than -7, which we actually already had written down. It was right up here. Now, do we need to graph these always if it's an or can we just go ahead and circle the final answer we got? The answer to that is you should graph them because from time to time some weird stuff comes up. Okay? So you should always graph them just to check and make sure that they are two separate things. You're going to see something like this happen from time to time. You'll get your number line. It's going to be an or statement. You'll have something over here, you'll graph it, and it'll look like this. You'll have something over here, you'll graph it, and it'll look like this. Now, this is an or statement, so we want to keep anything that's covered by one or the other or both. What numbers are covered by one or the other or both in this case? What's that? Where they overlap? Yes, those are covered by one or the other or both. Are there any other numbers that are covered by one or the other or both?
Numbers.
I'd say the whole number line is, right? If it's an or statement, it doesn't have to be where it overlaps. It's where anything is covered. Every single number on the number line is covered. Our answer for this is going to be all real numbers. So I want to keep an eye out for that. Questions? And we're going to see this come up, so this will be an example here in just a minute, too. Questions? All right, there's one other type of inequality that you might see. Looks like this. It kind of looks like our answer from a couple examples ago, right? Kind of got two signs in it. The only difference is that A is not by itself right now. So we're going to get A by itself. And there's two ways to do this. I can show you both. You could split it up into two separate inequalities. This is kind of the longer way. I'll show you this first, and then I'll show you kind of a faster way that some of you might like and some of you might not like. So we're going to split this up. I'm going to take one half of the equation and write it separately. -81 is less than 8a minus 9. And then I'm going to take the other part of the inequality and write it as a separate equation. 8a minus 9 is less than or equal to 47. And when you do this, when it comes in this form, it's always going to be an and in between. So when you see an equation that starts out this way, it's always going to be an and in between. And then we'll just solve it the way we did that and equation, or that and inequality a moment ago. So just really quickly go through and solve this. Adding 9 to both sides is going to get us 72, negative 72 plus A. Dividing by 8 would get us negative 9 plus A. Go over here, do the same thing, adding 9 to both sides. Divided by 8. And this is an and. I'm sorry. Oh! Sorry. Is that better? Thank you for catching that. We could go ahead and graph these and see what it looks like. You're going to see overlap usually with these. We've got from negative 9, A is greater than, A is bigger than negative 9. This one's kind of flipped around, so it's sometimes harder to read and figure out which way it should be going. But we do want the values that are bigger than negative 9 here. The other one is A less than or equal to 7, so less than or equal to 7. Since this is and, we're looking for where these two things overlap. They overlap not at negative 9. They do overlap between negative 9 and 7, and they do overlap at negative 7. So our final answer is going to be from negative 9 to 7. X is going to be, actually A, is going to be between negative 9 and 7. A is bigger than negative 9, less than or equal to 7. I'm sure some of you are already seeing some steps here that you probably would do in your head. For example, many of you would probably just jump straight from this answer to that answer. Any questions on that one? How we do the what? These ones? These guys? Well, this is basically has two pieces of information in one. We're kind of using the A. The A is doing double duty. Okay, so when I read this, I can look at this and say, okay, first of all, A is bigger than negative 9. Would you agree, since the alligator's eating the A must be bigger than negative 9. And then also, A is less than or equal to 7, because the alligator's eating the 7 there. So this is just it's a form of notation that's showing you that A has to be between those two numbers. It's bigger than the one, it's smaller than the other, so therefore it falls in between. It does. It does. Negative 9 is less than A. I always look at it from the variable's point of view, though. So from A's point of view, A is what compared to negative 9? A is bigger. A is bigger than negative 9. It's less than 7 or equal to 7, so it must be between negative 9 and 7. Anybody interested in seeing maybe a more efficient way of doing this? Yeah, it's kind of weird, but it's just it's the rules of algebra kind of expanded to a three-sided inequality. So you can solve this just in this form. You don't have to split it up. We could take this compound inequality and we could just say, okay, I'm just going to get, the goal is to get the A by itself. Okay? Plus 9 to all sides. And we're used to doing the same thing to both sides of the equal sign. Now we have three sides we have to worry about. I added 9 to both sides. We got negative 72 less than 8a less than or equal to 56. A is almost by itself. What am I going to do to all sides to get a by itself? We could divide it by 8. Divide by 8 on all sides. Negative 72 divided by 8 would be negative 9. Less than a, less than or equal to 7. You like that? Seem weird to you because there's 3 sides instead of 2? Some people don't like it because that seems weird. Okay, so that's our basic inequalities. Anything from that that you'd like to go over a little bit more before we move on to the advanced stuff? Again, I know this is a long day of notes, but just get it all out of the way in one day. All right, equations and inequalities involving absolute values. The equations part of this we've already covered. These are the exact same notes that we took the other day when we talked about equations, with one addition. We have to talk about when we split up the equation or the inequality, because anytime you have an absolute value, you're always going to split your equation or inequality into 2. When we split it up, we have to determine whether we're going to get an and or an or. Now, it turns out for equal sign, it's always an or. When it comes to inequalities, it's either going to be an or an and. It's important that you get that right, because that determines whether you're looking for overlap or whether you're looking for 2 separate regions or anything that's covered by either of them. So we're still doing the same thing, and I didn't write the KFC part up here, but note that when we start with the absolute value less than a, what happens? First, we drop the absolute value, but the rest of it stays the same. On the other equation, or inequality, we drop the absolute value, so we keep everything. We flip the sign. Remember, it was a greater than over here, and now it's turned into a less than. And we change the positive a to a negative a. So it's the same thing that we did before. It's still that keep, flip, change thing, or some people do drop, flip, switch. Same idea. The only difference here is, what do we throw in between those 2 inequalities? Is it an and or an or? Do you remember doing this last year? You talk about less than and great or. No? Is that a new thing? All right. Here's how I remember it. Here's how I remember it. If the absolute value was greater than the other side, then it's an or. So I look at this absolute value as greater, or, no, that's not how you spell greater, but emphasize on the or. Greater, it becomes an or. On the other hand, if the absolute value is less than, then it's an and. Now, it's very important that you get the correct word in between there, because your graph, your answer is going to be different depending on whether it's an and or an or. So greater, less than. A couple quick examples here, and then we'll be finished. Scratch this interval notation part. We're going to give our answers the same way that we have been. Okay, let's do a couple examples. We can come back and answer some questions. That's the same stuff. Okay, here's an example. This one is an inequality, but it has an absolute value in it. Can I go ahead and combine that 8 and that 9 together? No. No, we can't. The 8 is being multiplied by something that the 9 is not, so we cannot. So our first step is always to isolate the absolute value, whether we're dealing with equations or inequalities. So we're going to start by getting rid of this 9 over here, subtracting 9 from both sides. And then we need to get rid of that 8 there. How are we going to get rid of that 8? It's multiplying, so we need to do the opposite. Let's divide by 8 on both sides. That cancels. We've got the absolute value of r over 7 less than or equal to 1. Absolute value is isolated. Now it's time for us to split this into two inequalities. We're going to split them up. Now before I start splitting them up, can you tell me what word is going to go in between those two inequalities? And or? And, why? Because the absolute value is less than something else. So it's going to be and. Less than. So looking at this sign here is going to tell us that this is and. And it's not just the sign, really, it's the relationship of the absolute value to the other side. All right, let's split it up. Same way that we did before. My first inequality is going to be exactly the same, but without the absolute value. My second inequality, we need to do the KFC or drop flip switch, however you do that. Drop the absolute value. Now this time the flip part is important. The sign was a less than or equal to. We're going to change it to a greater than or equal to. And what's going to happen to that positive one? Negative one. Now we've got two simple inequalities to solve. We will solve them, we will graph them, and because this is and, we want to look for where they're overlapping. That will be our solution area. So multiplying by 7 on both sides is going to get us r less than or equal to 7 and r greater than or equal to negative 7. Graph these. So we put negative 7 and 7 in the appropriate places on our number line. R is less than or equal to positive 7. R is greater than or equal to negative 7. And because this is and, we want to look at where these two graphs overlap. They overlap in between. They're also going to overlap at negative 7 and at positive 7. So our solution is between negative 7 and positive 7. Any questions about what our solution is before we write it down? All right, here we go. We're going to write down that weird thing now. So R is between negative 7 and positive 7. Signs are always going to point to the left. They're both less than or equal to. All right, stick with me here. We got a couple more to do. Any questions? Okay, this is going to be a weird one. We dealt with some weird ones when we were doing inequalities before. So fair warning, this will be a strange one. Write this down. This will be one that we can jump straight to an answer early on, or if we miss that, we can continue on and we can still get the correct answer. Our first step would be to isolate the absolute value, so we'll subtract 8 from both sides. We're going to get the absolute value of 2x minus 1 less than negative 5. Let's split this up. This one is and or? And, because the absolute value is less than. You're correct. So you could jump off and go ahead and write the answer down. If you catch that, we'll come back and look at it in just a minute. We've got a couple people already recognizing that this is going to have a weird solution. All right, flipping my sign, changing the -5 to a +5. So I'm going to work it out kind of the long way, and then we'll come back and talk about how we could have stopped before we even got to the step that we're on right now. Adding 1 to both sides. And dividing by 2. Doing the same thing over here, adding 1 to both sides. Dividing by 2. Over here, it should be positive because remember we do the KFC thing, so we flipped the sign and we changed the -5 to a +5. Other questions? I heard another question. All right, now what happens when we graph this? This is an and, so we're looking for overlap. We've got -2 and 3. This solution is saying that x must be less than -2, and at the same time, it must be greater than +3. So we need to find where those two things overlap. Where do they overlap? They do not overlap. Therefore, our answer is no solution. All right, we had an and, which means we need overlap, but there is no overlap, so it's no solution. Now, do you have any questions about the process here before we go back and talk about how we could have gotten to that answer earlier on if we'd been paying attention? And I know that some of you, many of you were, and caught this. So even if you missed this, you would still come up with the correct answer, which is no solution. Can somebody explain a thought process that can lead us straight from this statement right here to that same answer, no solution? What would your thought process be? An absolute value can never be negative, right? So how is it possible for an absolute value to be less than -5? That would force the absolute value to be negative, but it can't be a negative. So it doesn't matter what I plug in for x, that statement will never be true. Therefore, there is no solution that would make it true. Right now, I would like you to look at this problem. This is different. I switched the sign in the problem. Go ahead and write that down on your paper. Go ahead and get the absolute value by itself and see if you can determine what your answer is going to be without actually going through the whole process. We're going to get a different answer this time around. So write it down. Get the absolute value by itself. It's going to be very similar. I just switched a sign in it. So get the absolute value by itself. You're going to get absolute value of 2x minus 1 greater than what? -5 still. Now use your logic here. When is an absolute value of something going to be bigger than -5? Never? All the time, right? An absolute value has to be bigger than a negative number, right? Because an absolute value is always going to be greater than or equal to 0. So this statement is going to work out to be true all the time. So we could jump straight from here to say all real numbers. Now if we miss that, we can still go through the whole process. Notice that in this case, because the absolute value was greater than the other side, we have an or. We go ahead and solve everything. This time around, we get a graph that looks like this. Now, or means we keep anything that's covered by either one of our graphs. And I would say that everything is covered by that same graph, or by that graph. Yes?
You still have to specify that it can't be -4 through -1.
Would you have to specify that it can't be what?
-4 through -1. Greater than -5. Unless we're already in this
No. Logically, it really doesn't matter what's in here, and it really doesn't matter what's over here. If you got an absolute value that's bigger than a negative number, that's always going to be true. Okay, so this absolute value, the smallest that it could possibly be would be 0, right? It can go all the way up to infinity if you wanted it to, but it can't go below 0. So there's no way that it could ever be smaller than -5. This statement is saying that it's going to be greater than -5. I would say no matter what you plug in for x there, no matter what, it's always going to be a true statement. So the only answer I would need to this is all real numbers. Okay, we've got one more. Don't do that thing. You pack out this stuff. I'd like you to work this out on your own. There are a couple tricky things about this problem. Actually, can we quit this right now and say, oh, there's a negative number on the other side of the inequality? No, you cannot quit until you've gotten the absolute value by itself. So do a couple steps of algebra, get the absolute value by itself. I think at some point you're going to end up dividing by a negative. Make sure you take care of, don't make that mistake that I made earlier where I forgot to flip my sign. Is this one of those ones we can get a quick, easy answer? All real numbers are no solution? No, it's not. We're not comparing it to a negative number this time. Will this be an and or an or when we split it up? The absolute value is greater, so this is an or. Keep everything the same, and then flip your sign, change the +6 to a -6, and we've got two equations that we can solve, inequalities rather. Smaller. So that's just going to be our answer. Okay, so we dealt with inequalities today. The more advanced flavor of the problems are going to have absolute values. Thank you for your attention. If you have any questions, stop by and let me know. I can write you past your next class.